Hi. This is the first chapter of this course. We will talk about the fourth fundamental quantity, which is the electric charge, and its relationship to a quantity called an electric field. You may have encountered positive and negative charges before in your high school physics and realize that these types of charges are present in the nucleus of an atom. You must review that, and use that as the basis for this chapter. This chapter will be comprised of 3 modules. The first module will be on the basics of electric charge, including the 2 types and their interactions. The second module will then answer why these charges interact with each other, and the reason for that is the electric force. Finally, the last module will talk about the electric field and why charges exert forces on other charges. Module 1.1, Electric Charge. Electric charge is the property of matter involved in electromagnetic interaction. It is one of the fundamental properties of matter, together with length, mass, and time. The word electric comes from the Greek word of amber, which is electron. Ancient Greeks used to rub things with amber and found out that some things attract and repel after rubbing. The first part of this course will focus only on electrostatics, which deals with interactions between charges at rest. Electrodynamics, which deals with moving charges, will be discussed in the second part, on the topics on magnetism. Benjamin Franklin was the one who categorized charges as either positive or negative. Electrons in an atom are negatively charged, while protons are positively charged. Whenever there are more positive charges than negative charges in a material, we say that that material has a net positive charge. When there are equal numbers of positive and negative charges in a material, then that material is said to be neutral. Electric charges interact in such a way that they repel charges with the same sign and attract charges of the opposite sign. This has come to be known as the law of electric charges. A positive charge will then repel another positive charge but will attract a negative charge. Most of the interactions in nature are electric or based on charge-to-charge interactions. In this picture, most of the forces involved in a man skiing are electric. The force between the water and the ski, the tension in the rope, and the air resistance all involve atom-to-atom interactions. The only non-electric force acting on the skier is the force due to gravity or weight. Similar to energy, the sum of all the electric charges in a closed system must be constant. This means that if an atom in a neutrally charged material loses an electron, that atom becomes positive, while the atom receiving the electron becomes negative. However, the total charge of the material still remains neutral. The natural unit or quanta of charge is the magnitude of the charge of an electron. It is denoted by the symbol E, and has a magnitude of 1.602 times 10 to the power of negative 19 coulombs. An electron then, has a charge of negative E, while a proton has a charge of positive E. Quarks, on the other hand, have fractional charges with respect to E. However, quarks don't exist in isolation and always tend to form pairs or groups, such as protons or neutrons. This means that their total charge is quantized based on the natural unit of charge E. There are 3 basic ways to charge an object. We mentioned the first one used by ancient Greeks, which is charging by rubbing. The next charging processes will depend on the type of material. Materials can be classified on how they permit the flow of charges. Conductors allow the easy flow of charges within them. Most conductors are metals such as iron or copper, but liquids can also be conductors. The charging process involving conductors is called conduction. When you get electrocuted, you are actually charged by the process of conduction. Charging your smartphone, or any electrical or electronic devices, are also done using conduction. Insulators, on the other hand, blocks the flow of charges. Examples of these are plastic and glass. One application is to prevent you from electrocution. Electrical wires made of copper are usually coated with plastic or rubber to prevent the flow of charges from the wire to your hands if ever you touch it. There are also materials with properties that are in between conductors and insulators, and these are called semiconductors. They are insulators at room temperatures but can become conductors at very high temperatures. This is the reason why semiconductors are used in computer processor chips, since these devices operate at high temperatures. Lastly, there are materials which permit the flow of all charges without any resistance, and these are called superconductors. They are the perfect form of conductors and provides no loss in energy. Currently, superconductivity only happens at very low temperatures. If room temperature superconductors are developed, then you won't have to pay for the generation or transmission losses in your electricity bills. The last charging process is by induction. This is charging with no physical contact, in contrast with rubbing and conduction. In this process, the object acquires charge with the opposite sign. Suppose you have a metal ball, and you place a negatively charged rod close to it. Since negative charges attract positive charges, then there will be a buildup of positively charged atoms near the rod and negatively charged atoms on the opposite side of the ball. These buildup of charges are called induced charges, and they lie only on the surface of the material. To complete the process of charging by induction, the metal ball is grounded so that only positive charges will remain. An essential application of induction is in electrostatic painting. The spray of paint is negatively charged, and the metal object to be painted is grounded, making it positively charged. In this manner, the paint will become more adhesive to object since negative charges attract positive charges.